Hello everybody, thank you for checking out my video on central and inscribed angles. As I'm recording this, it's unit 6, but most semesters for me is unit 7. A very important prerequisite skill, understanding that angle 1 here works with a certain angle. And as angle 1 opens up, it's opening up to purple. So do you know which angle or which arc angle 4 works with? So angle 4 is going that way. Angle 4 is working with the green arc. And probably the best question, do you know which colors, there's two, that angle 5 is working with or opening up towards? And angle 5 going that way, hopefully you said green and teal. So you'll need that skill a little bit later. In the meantime, starting things off with central angles. So basically a central angle has this vertex in the center. As you see, B is the vertex here. And it's always going to be the same as whatever arc it is. So angle B opens up this way, and if this arc is like 120 degrees, then angle B is going to be 120 degrees. Central angles and their arcs always the same. Just make sure that it's in the center, not just somewhere random. We'll do this part on another video. So find each arc measure. I got a 43 already, DE on this arc. Since 79 is a central angle there, I know that this arc is 79. So remember that this diameter is cutting the circle in half. Looks a little bit off, but that dot means this is the center, and DG is going through it, so DG is a diameter. So I need to do 180 minus 79 minus 43, because it's a half circle. It's got to add up to 180. So when you subtract that, you get 58 for arc EF. Note, arcs are measured, at least in this case, in degrees. We'll talk about how long they are as part of their circumference. Meanwhile, G to H, I need to find D to H, but I know G to H already. G to H is automatically the same as this because these are vertical angles. Very important geometry rule. When two lines intersect, their opposite angles will be equal to each other. And that's what's happening right here. So that's the 43. And again, we got the 180 rule. 180 minus 43 leaves us with 137 for arc DH. Meanwhile, I think I found all of these. G to E, G to E is the 79 and the 58 one combined. Make sure you go the shortest way, not the other way just yet. Arc HF is the 43 degrees plus the 79 degrees. So when you see 3 letters, this is a major arc. It'll be more than 180 degrees. So you're going to start at E. I'm going to change colors for this. Start at E, go towards D, and all the way around to G. So arc EDG is the 43 degrees I was just at, plus the 137 that we found earlier, plus that other 43. So the blue part. And hopefully you can write the numbers down for HDF. So if you did that, 137, 43, and 58. HDF was from H, go towards D, and then all the way to F. Better view on that page. So much like in our original flipbook, sometimes we'll have expressions that we can work with. And note, our expressions were always equal to 90 or equal to 180 or equal to each other. But now that we're in circles, now we'll also have an equals 360 case. Because if we got the whole circle and that's what we have, it'll total up to 360. I know that's 143 degrees. I know that one's 7x minus 6. I know this little arc is 26 degrees, and this one is 9x plus 5 degrees. So if I add them all up, and I set them equal to 360 because we got the whole circle represented. Combine like terms, 9x and 7x is 16x. Combine all your constants, 5 and 143 is 1 148. Minus 6 is 142. Plus 26 is 168 or 158. Yep, it was 168. I went ahead and subtracted 168 to get 192, and of course we divide by 16 to find that x is 12. And this is a really good answer. Remember, most of the time, geometry is not going to be about the x. It's going to be about the picture. Now, note, all they did was ask for x up here. That's great. But I'm also going to ask for arc MJ. So arc MJ has this little arc-like loop over it. That would be 9 times 12 plus 5. I simply plug in my 12. I believe it's 108 plus 5, which is 113 degrees. And if I plugged in there, whatever I get, the four of them should add up to 360. The bottom part here will go in a different video. Like I was telling you, there's one little section that I wrote later. Now, meanwhile, in inscribed angles, what you're learning about in this video is two different types of angles in circles. When angles are in the center, and when angles, their vertex is on the arc, aka an inscribed angle. And the way this works from earlier, like you already saw with the colors at first, if this arc is about 70 degrees, then the angle, notice it's way too little to be 70. It's always half. Inscribed angles are half of their arc, which is what it says right below this little box. The angle is half the arc. So you know how this is already 180 because it's a half circle? Well, that angle up there, angle B, is an inscribed angle, and it opens this way to all of this. It opens for everything from A all the way around to C. And it's inscribed, so you take half, and it does look like a 90-degree angle. Now, note, angle B makes this arc from A to D, but also angle C makes this arc. So B and C are automatically the same. Just to summarize again, a central angle is always the same as this arc. An inscribed angle is always half of this arc. So let's find some measures. They only gave us one angle and one arc, but I'm going to use this to find out a whole bunch of stuff about this circle. Being at 65 is inscribed and it opens this way, I do 65 times 2 to get 130, because remember, the angle is going to be half the arc, so I had to times by 2. I wouldn't divide by 2 because that would be 32.5, and this arc is way too big. If our whole circle is 360, TS better be at least 100. Looks like we got a diameter here, so do you know what's true about this side of the circle? It's got to add up to 180, so 180 minus 130 makes 50. Same thing on the other side, we got a 106. Hopefully you know what the other side is going to be. Maybe pause it and think about it. 180 minus 106 is 74 degrees for this one. So I've got every arc. Now let's take half of a lot of these arcs because we got a lot of inscribed angles to find. So let's start with angle T. Do you know which arc? It was colors earlier, but now we're using numbers. Which one of these numbered arcs? Hopefully you're saying it's 106 that it's opening up towards or working within. You do half of 106 to get 53. I believe that's that one. Next up, do you know which number is coming from this angle, RSQ? Not one of the ones that was asked for, but it would be half of this arc over here. Half of 74 is 37 degrees. But the one next to it doesn't necessarily open up to the same one. Where is this angle opening up to? It's opening up to the 50, and half of 50 is 25 degrees. Got a couple more chances to make sure you got this. Let's see, angle SQR up here, which we weren't asked about, right here. Where's it opening up to? Oh, it's opening up to that 106. So it's going to be 53 degrees as well, just like this one. because they open up to the same arc. Got all except this little one right here. Which arc are we opening up to with angle QRT? Well, it's opening up to 50, and half of 50 is 25. No, nope. They asked for TQ, which was 50 degrees. Angle SQR, right there, we found that a little bit earlier. That was half of 106, or 53 degrees. The arc from S to T is 130, and the measure of arc QR was 74. I think I did something wrong. QRS. I wrote something in the wrong place. QRS, that was, I wrote RQS in that spot. QRS was not 53. What they're asking for here, I actually need to go back and highlight, because this is a really good one to ask about. What they're asking about with QRS is from Q to R to S. They're looking for this whole entire angle, which had a 25 and a 65 in it. That's 90 degrees. I got that from 65 plus 25. So let's set up a couple equations. 71 and 16x minus 2. Do they add up to 180? No. Do they add up to 90? No. Do they make a whole circle? No. Are they equal to each other? No. I know I wrote equals, but I said they're not equal. The angle is always half the arc. But be careful when you set that up. Think about this for a second. In order to make them equal, which one do I need to multiply by 2? Do I need to multiply the arc by 2? Or do I need to multiply the angle by 2? And hopefully you're saying the angle is the one that needs to multiply by 2. So it's really 142 equals 16x minus 2. I'm going to add 2 and divide off the 16. And I believe x is 8. 8 or is it 9? Okay, I was definitely 9. It's not a much to plug in here, but if you do plug in 9, 16 times 9, and then subtract 2 should make 142. Similar question over here. 5x minus 27 and 2x minus 5. They are not equal to each other. But they will be equal if you multiply one of them by 2. Which one do you need to multiply by 2? What's the angle that would be smaller? Like, remember, 65 times 2 makes 130. So again, it's the 2x minus 5. But if I'm going to multiply the angle by 2, I need to multiply both parts, making it 4x minus 10. Remember, when you get two x's, you want to put them together. It's easier to move the smaller ones. So I'm going to subtract 4x. When I subtract 4x, I'm down to 1x. Don't panic here because it looks weird, just like any other equation. You're trying to get x by itself. I get rid of minus 27 by adding 27, and 17 is my x. Again, note, we generally don't ask for x. It's asking for the measure of arc EC. So I'm just going to go to arc EC and plug in my 17. 5 times 17 minus 27. And that made 58 degrees for that. Guess that means if you plug in down here, you would get 29. Yep, you would get 29. And then the last part of my flip book for today, remember, like, if they don't give you any numbers, it almost seems like something's wrong. But as soon as your circle is cut in half, you know you got 180. Remember, angle W is an inscribed angle making this arc. And inscribed angles are always half. So that's 90. Couple delta samples since I have a few seconds left on this video. Like the delta questions, arc SU is 92, and they're just asking for angle STU, so that'd be 92. It's a central angle. Arc GJ is 56, and we're looking for this angle, so half of 56 is 28. To get a little bit better, where you got to do like 2 and 1. The inscribed angle was 34 on this one. Almost messed up. So when I go to this arc, remember it's going to be 68. I had to times 2. When I go back to the